This is a mini lesson on why multiplying by the reciprocal works. Whenever I was a student, middle school, high school, I would do these math problems according to how the teacher told me to do them, but I never really understood why some of the things that we did, like to divide fractions we multiplied by the reciprocal, I never understood why that worked, and I never questioned it. As I got older and I started teaching, it became important to me to understand why it works. And so that's why I'm going to explain it to those of you that need to know that now. First of all, you don't always have to multiply by the reciprocal in order to divide fractions. Sometimes it's quite simple. 8 divided by 2, that can be divided with a whole number. 8 divided by 2 is 4, and 21 divided by 3 is 7. And so this comes out quite simply without having to multiply by the reciprocal. If you can divide the two numerators and you can divide the two denominators, you can simply divide the fractions. However, it's not always that pretty. Take the example of 5/10 divided by 5/6. I can divide 5 by 5. 5 divided by 5 is 1. But 10 divided by 6, if I were to work that over here, I see that 10 divided by 6 equals 1 4/6, or 1.6 repeating. And this would not be considered in simplest form. So there's a method that we use, and it's called multiplying by the reciprocal, to work this problem out instead of working with decimals, especially repeating ones. So I can write the problem like this, where I have 5/10 over 5/6. This is a fraction bar too, but it also represents division. It means 5/10 divided by 5/6. It's not in simplest form, and so to get it in simplest form, I can get rid of the denominator by making it 1. Well, to make the denominator 5/6, 1, I have to multiply by its reciprocal, 6/5. And if I do that, it's like the golden rule. We follow the golden rule a lot in math. If I do it unto the denominator, I need to do it unto the numerator as well. So I'm going to multiply it times 6/5. Now down here in the denominator, this is all going to cancel out, and this is going to become 1 whole. And then up top I have 5 times 6 is 30, and 10 times 5 is 50, and 30/50ths simplifies to 3/5. And so it's this method which is much easier to deal with than this, and that's one of the reasons that we multiply by reciprocals when dividing fractions. Here are just a few more examples real quickly. This is the one I showed you at the very beginning that can be divided from the very start. 8 divided by 2 is 4, 21 divided by 3 is 7. But I want you to see that it works when you multiply by the reciprocal as well. Again, this bar means to divide. It's not in simplest form when it looks like this, so I need to get rid of the denominator. I get rid of the denominator by multiplying it by its reciprocal, 2/3 times 3/2. And since I multiplied the denominator by the reciprocal, I have to remember that golden rule, and I need to multiply the numerator by the reciprocal as well. All of this cancels out and becomes 1 whole, as down on the bottom. And then I have 8 times 3, and 21 times 2, and I have 24 over 42, and I need to simplify, or I can remember to simplify before I multiply. I know that 2 goes into 2 once, 2 goes into 8 4 times, 3 goes into 3 once, and 3 goes into 21 7 times. 4 times 1 is 4, 7 times 1 is 7. And if I were to simplify this by dividing by 6, I would also have gotten 4/7. So one final problem that shows how multiplying by the reciprocal works for division. I have 4 divided by 1/2. I'm going to multiply 1/2 by its reciprocal, which is 2 over 1, to get rid of that denominator and make it 1. This all goes to 1, and so I must multiply this times 2 over 1 as well. It's the golden rule. And then I want to rewrite, just so that I remember 4 whole is 4 over 1, when you write it like a fraction, times 2 over 1. 4 times 2 is 8. 8 over 1 is the same thing as 8 divided by 1. 8 divided by 1 is 8. And that's why multiplying by the reciprocal works for dividing fractions.